If you're in technology, you know that performance monitoring is full of myths and manual struggles. Today, I'll show you how to uncover hidden temporal patterns that most tools miss so you can predict problems instead of just reacting to them. Let's start with why this is so hard. In the technology industry, especially with distributed systems and microservices, performance data is vast and noisy. Generic tools like APM dashboards require endless setup and still fail to spot recurring patterns. At quarantadue.ai, every MCP workflow starts from the real tool interface, not from a generic prompt. The goal is simple. Keep the expert in control while the system structures the evidence. Inputs, reasoning, and outputs stay connected in one reviewable flow. Now the results become easier to compare, easier to review, and easier to explain. Why? Because they focus on real-time alerts, not long-term trends. Engineers end up digging through logs, missing the subtle weekly spikes or seasonal loads that cause crashes. It's like trying to forecast weather by looking out the window. You need historical analysis. The real challenge is that periodicity isn't obvious. A system might degrade every Tuesday at 3 p.m. due to a backup job, but without automated detection, you'll only notice after users complain. This leads to firefighting mode, wasted resources, and unreliable services. Now, let's dive into the technical method. AnalyzeTemporalPatterns uses scientific approaches like spectral analysis and seasonality detection. It processes time series data from your processes, looking for cycles and repetitions. Key concepts include autocorrelation to measure pattern strength and Fourier transforms to break down signals into frequencies. This isn't about simple averages, it's about quantifying rhythm in your systems. A common misconception is that any monitoring tool can do this, but most just show graphs. They don't analyze temporal structure. Our software differentiates by applying statistical models to identify exact intervals, whether daily, weekly, or custom, and flags anomalies against baselines. Think of it as giving your data a heartbeat monitor. Next, the software solution. AnalyzeTemporalPatterns ingests data from logs, metrics, and traces. It establishes baselines for normal behavior, then calculates periodicity scores. The audit trail tracks every analysis for compliance, and scenario modeling lets you test what-if changes. For example, you can simulate how a new deployment might affect weekly patterns. This turns raw data into decisions. Let me walk you through a hypothetical example. Imagine a retail platform with microservices. Variables include user traffic peaks every Friday evening and database maintenance every Sunday at 2 a.m. AnalyzeTemporalPatterns would detect these patterns, correlate them with error rates, and show that the Friday peak causes a 20% latency increase. You'd then adjust scaling rules proactively, avoiding downtime. The outcome? Measurable improvement in reliability without claims, just data-driven insight. For compliance and reporting, the software generates clear reports. Stakeholders get readable summaries with visual trends, and audits are streamlined with detailed logs. This aligns with regulations like SOC 2 by demonstrating systematic monitoring. Reports highlight pattern deviations, so teams can justify investments and prove operational control. In closing, AnalyzeTemporalPatterns gives you the power to see time as a dimension of performance. You'll predict issues, optimize resources, and move from chaos to clarity.